Hey everybody, this is Mr. Longo and I'm back to talk to you guys about even or odd functions. So an even function means if you substitute a negative x into the function, it's going to give you the exact same thing. Nothing happens. So that means the graphically will look like it's a reflection over the y-axis. An odd function means if you substitute in a negative x, every term of your original function is now opposite. So all positives become negatives, all negatives become positive. So that graphically looks like a reflection over the origin, meaning you're just switching your x and y positive and negatives, okay? So when we're graphing, again, an even versus odd function. So we're going to do odd first. Odd simply means it is a reflection over the origin, meaning all negatives become positives and all positives become negatives. So 0, 0 is obviously the same. Negative 3, 5 becomes 3, negative 5, and we just go plot a dot. Negative 4, 3 becomes 4, negative 3. And negative 6, 3 becomes 6, negative 3. And all we do is switch all of our x's and y's from positive to negative or vice versa, and you have an odd function. It looks like a reflection over the origin. Now, even is just a reflection over the y-axis. So, negative 6, 3 becomes 6, 3. So look, we didn't change any negatives here. We're just reflecting. You can also count like you learned in geometry. You're 4 away from the y-axis, so you're 4 away from the y-axis again at the same level. And negative 3, 5 becomes 3, 5. And then we connect the dots, boom, 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 and you can see what an even function looks like, okay? So it's just a reflection over the y-axis. So using graphs to determine even and odd is pretty simple. It's the algebraic ones that are a little bit different, which is why we practice composition and substitution already. So all you have to do for these to determine if it's even or odd is to substitute negative x in. So what we're doing is f of negative x, and we're going to see what it equals. So we have a negative x to the 5th power minus 2 times a negative x to the 3rd power. Whenever you take a negative and put it to an odd power, it stays negative. So this is negative x to the 5th minus 2, which right here we have x to the negative x to the 3rd power, which is still a negative x. Okay, turning it to plus x cubed, because negative times a negative is going to become positive. We see that everything is opposite. We have a positive x to the 5th became negative x to the 5th, and a negative 2x cubed became a positive 2x cubed. Since they are opposites for each term of the function, that becomes odd. Okay? So why don't you try the next two? Pause the video, substitute negative x into the functions, and see what you get. Give it a try. Okay, so for this one, you have g of negative x. So we had a negative x squared plus 5 times a negative x. That gives us x squared minus 5x. This is neither, because the x squared stayed positive, but the 5x switched. In order for it to be odd, every term needs to switch. In order for it to be even, they must be identical. Okay, so this one is neither. The last one, 2 times the negative x squared plus 5. Negative x squared becomes positive again, so 2x squared plus 5. Since these are exactly the same, this is an example of an even function. Okay? So while we're substituting things in, I just wanted to take a quick moment to talk about finding the average rate of change from a certain part of the function. So to do this, we're going to use substitution and then use rate of change formula or slope. So what we're going to do first is find f of 1. And that just means 1 cubed minus 2 times 1 plus 1. And all we have to do is evaluate that. And that's going to be equal to 1 or 0. Because 1 minus 2 plus 1 is 0. And then you do the same thing for f of 3. We're just going to do 3 cubed, which is 27, minus 2 times 3, plus 1, and that is going to give us 22. So what we have here is when we plug in 1, that gives us the coordinate 1, 0. And when we substitute in 3, we get 3, 22. And now all you have to do is go old school slope or rate of change formula, which is y2 minus y1 divided by x2 minus x1. And we get 22 over 2, which means the rate of change just from 1 to 3 happens to be 11. That's why it is an average rate of change. This isn't a line, so this does not have a slope, so to say, but you can figure out the average rate of change between two sections of the actual function. In this case, we did 1 to 3. All right, that's it for this video on even and odd functions. This is Longo, and I'm out. See you, bye.